In the previous videos of this week, we looked at deployment environments and different strategies for deploying our application, right? And now these topics would have given you an idea of how important and time consuming deployment actually is, right? Because we have to ensure that the code which is built by multiple people, it is integrated together, it is tested sufficiently, and it is correctly deployed to the live environment, right? Without any bugs or defects. And all of this can be time consuming. So in this video, we are going to look at a concept which is known as continuous integration. And what is continuous integration? It is a way of automating the integration and the deployment process of software applications. So let's see how it works, right? So we have the version control system, right? It takes care of the different versions of our software, right? And we saw what a staging and a deployment server are. And in this video, we look at what a continuous integration server is, right? So now let's look at the continuous integration process, right? So it starts off with developers writing code and testing it, and finally they commit the code to the version control system, right? And what happens when after each individual commit, the continuous integration system or the server pulls this new code, right? And it builds and tests the code on the continuous integration server, right? It runs unit and integration tests and it checks for errors, and all of this is done automatically. And if there are no errors, then it sends a message to the deployment or the staging server that it is ready to deploy, right? And now the deployment server, it pulls code from the version control system, right? And it does one more round of building, testing, and finally it deploys it. And then it notifies the continuous integration server that the deployment is complete. So in this way, we see that most of the building, testing, deployment, integration, all of this can be automated by using scripts and by using the continuous integration server. So now that we have seen what the continuous integration process is, there are some best practices which we can use so that the CI or the continuous integration process is carried out efficiently and smoothly. So let's look at these best practices. So the first thing is that it is essential that you maintain a single source repository, right? So you maintain a mainline or a master branch, and most people should work on this branch most of the time. Of course, you can have few branches for testing new features, for bug fixing, etc. But most of the people should ideally work in the master branch at all times. The next thing is that it is imperative that you automate the build, right? So what does a build involve, right? So when you're building your code, it involves compilation, it involves copying and moving the files, creating database schemas, right? And most of these can be automated using build tools, right? For example, in Java, you have Ant and Gradle, and Node.js has a build tool known as Builder. So all of these tools can help you automate the entire building process, right? It's just that you have to write some scripts with the correct configurations, and these tools will help you automate the entire build. And not only should you automate the build, but you should make the build self-testing as well, right? Now, what does this mean? This means that you can create automated tests, right? That can check a large part of the code base for bugs, right? And let's say when a test fails, right? The notification should directly be sent to the developer responsible for that module, right? So a simple command should just start running the test suite, and appropriate notification should be sent to the responsible developer when any test fails. Another important practice is committing to the main branch every day, right? So how do developers commit? Or are they write code, they write tests, they build, and they check if there are any errors or not, and then they commit, right? And sometimes they check for conflict errors also. They need to check for conflict errors as well, right? So errors which can occur when others have already modified parts of the code which you have modified, right? Now, the problem is if you don't commit frequently, there are chances of more conflict errors, right? And hence frequent commits, they encourage developers to break down their work into very small chunks, right? So this is the reason why it is essential that you commit to the main branch every day. Now, another important practice is that each and every commit should automatically build the main branch on the integration server, right? So as we saw, the continuous integration server, it monitors the repository, right? So let's say every time a commit happens, the CI server should pull the new code, right, and build and do the integration testing, right, and should notify the developer who committed the code if everything is working correctly or not, right? So if all the all the tests pass, then great, right? The build is successful, right? So hence it is important to have a continuous integration server, right? And an example of this is Jenkins and CruiseControl. So this image is an example taken from CruiseControl, where it shows us a list of builds which have happened, right? And also the builds which have passed and which have failed, right? For how much duration, the time, right? Who has done the modifications and so on. Now let's say if our build breaks, right? If there are some errors, right? Another important practice is that these broken builds have to be fixed immediately, right? And it should be a priority of the developers to fix broken builds. And another thing is that we have to revert or take the system back to the last known good build, right? So that other developers who are working on the system can access the correct code base, right? This error does not percolate to their code as well, right? So it's important that we roll back the system to the last known good build. And finally, it is important that you automate the deployment process, right? Write scripts which will automate the deployment as well, maybe deployment to the staging environment. So this ensures that the latest code is always available in the staging environment. Now that we have seen what the best practices for continuous integration are, learners, let's reflect on this question of what are the benefits of using continuous integration? Maybe for the end users, for developers, for the organization. Can you think of what the benefits are? You can pause this video and think about the responses before proceeding. So what are the benefits of continuous integration? So one is that it reduces deployment time, right? So since most of the deployment, the building, testing is automated, there are scripts, there is the integration server which does all of these things, it minimizes the steps that require human intervention, right? And in a way, it reduces the deployment time. Now, second benefit is that it avoids this last minute rush, right, at release dates. So let's say a release date is coming up, right, where the team has to show some new feature to the client, and the developers have not committed their code in, let's say, weeks or even months, right? And all of a sudden, close to the deadline, they start committing their code. Now, do you see what problems will arise, right? There will be several conflicts, right? Because the developers are writing their code, and it's very likely that they will have conflicts because they have not committed frequently, right? And hence, when you follow the process of continuous integration, developers are encouraged and even mandated to commit to the main branch every day, right? And this helps in reducing conflicts as well. Third is that it is beneficial to end users as well, right? So let's say they want to see an initial prototype, or let's say the sales or the management team wants to show a demo of the tool, right? And all that they have to do is run it from the staging server, because the continuous integration server will tell the staging server to build the code, right? So you will always have an updated copy of the software system in one of the servers, right? So you can always see an initial prototype, and it's available to different teams as well. And it's beneficial for developers as well, right? So since they are committing their code frequently, it helps developers to create more efficient, more modular code. They write code in small pieces and commit, right? So this is beneficial for developers as well. So one drawback of the continuous integration process is that there is the initial effort, right, required to set up processes, to train people, to set up the integration server. All of this takes time, right? But in most cases, the advantages, it far outweighs the drawbacks. So in this video, we looked at the continuous integration process, right? And we looked at several best practices which are needed or which are essential for continuous integration to work well.